So welcome everybody to the third and last session of today's CSAE conference. This is on the environment. My name is Niclas. I'm at the University of Oxford, and it's my pleasure to chair this session today. Without further ado, thank you very much for joining us today, and I'll hand over to Ange Kakpo, who's the first speaker. So Ange, I'll just let you share your screen now. Excellent. So Ange, the floor is yours, 15 minutes.
Thank you. Thank you, Niclas. And my name is Ange Kakpo. I'm here to present to you one of the papers that I've been working on for my dissertation, titled The Effect of Weather Shocks on Millet Market in Sub-Saharan Africa. And I'm working on this with my advisor, Bradford Mills, and co-author, Stephanie Brunellet. So the motivation for this study starts with the fact that semi-arid areas of Sub-Saharan Africa are vulnerable to weather shocks, and specifically in areas where households depend heavily on rain-fed agriculture. One of the effects that has been heavily documented in the literature is that weather shocks affect both household production and market food prices, and those are two important pathways through which weather shocks can affect household well-being. So understanding those impacts is crucial in designing sustainable and effective resilience programs in Sub-Saharan Africa. There's been ample empirical evidence on the links between weather shocks and economic, social, or political outcomes in Sub-Saharan Africa. So we found that adverse weather shock conditions have been shown to reduce crop yields, to reduce household farm income, to reduce food consumption, and to also reduce livestock weight gain or milk production. But also weather shocks have been associated with increased infant mortality in Africa, and also household migration. But the other important channel through which weather shock can also affect households is market price. So we've seen in the literature that adverse weather conditions are associated with higher food market prices. But something that is also important is that weather shock can also affect market price seasonality, which is really pronounced in staple food market of Sub-Saharan Africa. So research today has not really explored the effect of weather shock on market price seasonality. So basically, price seasonality can be defined as the intra-annual variation of prices, whereby prices are low right after harvest, and then they increase over time and reach their highest level in the lean season before decreasing back towards harvest. So this study aims to add to the literature, to the huge weather shock literature, by investigating how rainfall-induced production shock can affect millet prices in Niger. And I'll explain later why we are focusing on Niger and why we chose millet. And to do this, we match a time series of high-resolution district-level rainfall data with millet production and millet market price data from Niger. And we do this in 2 steps. We believe that weather shocks will affect price already through millet production. So first, we use a district feast effect regression to quantify the effect of weather shocks on millet production. And then secondly, we use another district feast effect regression to look at the impact of weather shocks on millet price seasonality by using monthly millet price as a dependent variable. So we compute rainfall Z-scores by district and by year, and use that to construct measures of positive and negative rainfall shock indicators, and I'll explain how we did that in a bit. So why did we choose Niger, and why are you focused on millet? Niger is one of the poorest countries in the world, and agriculture is the main sector of Niger's economy. It contributes to their GDP for about 40%. And being a country that's located in Sahara, in a semi-arid country, Niger is frequently affected by weather shocks. And why are we focusing on millet? Millet is the primary staple crop in Niger, both in terms of production and in terms of consumption as well, but also in terms of sales, in terms of income that household gets. So many households, small households in Niger will sell millet for their income. They also consume millet. So millet can be targeted by policymakers as one of the ways to build resilience of smallholder farmers in Niger against negative rainfall shocks. So just a preview of the result that we found here. We find fairly symmetric production responses to moderate rainfall shocks, and I will explain later what we mean by moderate rainfall shocks. We find that positive rainfall shocks increase millet production by approximately 18%, while negative rainfall shocks decrease production by 20%. We find that strong negative rainfall shocks have a much stronger impact than strong positive rainfall shocks. We also find that negative rainfall shock exacerbates seasonality, while positive rainfall shock tends to reduce or smooth out price seasonality. So basically, negative rainfall shocks will increase price in the post-harvest season when prices are supposed to be low, and then they will increase price in the lean season when prices are supposed to be high. So that is exacerbating the effect of seasonality. The positive rainfall shock, on the other hand, decrease price in the lean season, which is the period when prices are supposed to be high. So we use longitudinal price and production data for our study. And our production data comes from 31 districts in Niger from 1985 to 2016. And the price data comes from 46 markets in Niger from 1990 to 2016. And we match the production and the price data with water data, specifically rainfall data from 1985 to 2016 at the 0.5 degree resolution. And just a bit about the cropping season in Niger. The rainy season starts in June and ends in September. The dry season begins in October and ends in May. So millet is grown during the rainy season from June to September, and it is harvested from October right after the rainy season ended till December. And the lean season, which is the period when millet stock are normally low, would run from January to September. So we constructed Z-scores. We use our rainfall data to construct Z-scores, like I was saying at the beginning. And we use the Z-score to construct our negative and positive rainfall shock dummies that we use in our regression. So a Z-score greater than 1 will be a positive rainfall shock, and a Z-score less than 1 will be a negative rainfall shocks. But we also test the robustness of our result using other thresholds. So we use the 0.7 and 0.5 threshold. So a Z-score bigger than 0.7 or 1.5 will be a positive rainfall shock, and a Z-score less than 1 minus 0.7 or minus 1.5 will be a negative rainfall shock. So we label the 1 minus 1 threshold here, if you can allow me. We label that moderate rainfall, moderate positive or moderate negative rainfall shocks. And the 0.71 is mild positive or mild negative rainfall shocks, while the 1.5 one is labeled as strong positive or strong negative rainfall shocks. So this is showing the percentage of district that has experienced positive or negative rainfall shock over time using the one standard deviation thresholds. And as you can see here, there is a strong year-to-year variation of positive and negative rainfall shocks happening in the district that we studied over time. So this is indicative of the fact that rainfall conditions in Niger are changing over time, and we expect this to affect millet production and to ultimately affect millet price and millet price seasonality. So I'm also showing here the temporal variation of production and price. And as you can see, production is fluctuating over time, but it is fluctuating in an increasing manner. So you can see the linear increasing trend of production. And that is indicative of the fact that there have been shocks to production. And the same thing for price. You can see that price is fluctuating over time in an increasing manner as well, not as much as the production one. But the peaks that you are seeing for price here is showing two things. It's first showing seasonality, right? So seasonality of price, like I was saying, prices will peak sometime in the season, but this is also showing that there have been shocks to production which are affecting price. So in some years, the peak will be higher than in others. So this is market price seasonality in Niger, what I was saying. And for this, we use the millet price data that we have, and we average that for each month. And we are showing this for the first month in the post-harvest season, which is October all the way to September, which is the last month in the growing season right before harvest. So as you can see, prices are very low. Prices are low early on in the post-harvest season, and then they increase in the lean season, which starts in January all the way to July and August, where they reach their peak, and then they decrease again when we approach the next harvest. So this is important in what I will show later in my results. So our identification strategy is a two-step one. We first look at the impact of rainfall shocks on production, and we use a district fixed effect to do that. So here, rain here is our rainfall shock indicators, which is showing the negative and the positive rainfall shock that we use. We are controlling for a linear time trend to capture, area expansion and technology advancement and everything that has contributed to millet production increasing over time in Niger. We control for a district fixed effect, and epsilon IT is the error term.
You have about 5 minutes left.
Thank you. So we look at the impact of weather shocks on prices already by interacting weather shock with month dermis here. So here we are looking at weather shocks in the previous season, and we are looking at the impact of that on monthly prices. And we control for year fixed effect, district fixed effect, and also month fixed effect here. So looking at the impact of positive and negative rainfall shocks on production, you can see, as expected, that positive production shocks are increasing millet production. Positive rainfall shocks, are increasing millet production, and negative rainfall shocks are decreasing millet production in all the cases that we presented here. And in the one standard deviation case, it is increasing production by 18%, and negative production are decreasing. Negative rainfall shocks are decreasing production by about 20%. So when you go to the 0.7 standard deviation threshold, you can find fairly similar results with the positive and the negative production shock, rainfall shock, I keep saying production, rainfall shock indicators. But then when you go to the 1.5 standard deviation threshold, you can see that the impact of strong negative rainfall shock is much larger than what we have found in the previous two cases, while the impact of strong rainfall shocks is not as large as the impact of strong negative rainfall shocks. So here we are looking at the impact of negative and positive rainfall shocks on price seasonality. So basically we are showing the impact that negative rainfall shocks will have on each monthly price, and we do the same thing for positive rainfall shocks here on the right. So as you can see, negative rainfall shock will decrease price early on in the marketing season. So this is the post-harvest season, right? And then that effect will increase over time. And it will reach its highest impact in the lean season. So basically what's happening here is that negative rainfall shocks are decreasing price when prices are supposed to be low, right? And then they are increasing prices in the lean season when prices are supposed to be high. So that is exacerbating the effect of seasonality. And when you look at positive rainfall shocks, prices decrease early also in the post-harvest season, but then that effect decreases over time and it reaches the lowest impact in the growing season, which is part of the lean season as well. So negative rainfall shocks tend to increase seasonality, while positive rainfall shocks are actually reducing the impact of seasonality. So we explain the impact of negative rainfall shocks here by the fact that, in the case of negative rainfall shocks, income that farmers get from cash crops of other production of cash crops will also receive a hit. And in that case, since it is common in smallholder agriculture in sub-Saharan Africa that farmers will contract debts in the growing season, many farmers, when they receive negative shocks, tend to go and sell their harvest in the post-harvest season in order to pay for the debts that they contracted in the growing season. So that results in an early decrease of price since many farmers want to go and sell their product. So we do the same thing with the other threshold, and we find the same results with negative rainfall shocks. As you can see, prices decrease early on and increase later in the lean season. And for positive rainfall shocks, you can see that here we have an early increase of price, but similarly to the previous case, prices will tend to decrease and reach their lowest level in the lean season. Same thing with strong positive and strong negative rainfall shocks. We find that prices decrease early on. The effect here is a bit larger than the two previous cases. Prices will decrease early on for negative rainfall shocks, and then they will increase later in the lean season. And for strong positive rainfall shock, prices will increase early on, and then they will tend to decrease and reach their lowest level, similarly to the two previous cases, and go back up in September, which is the last month before harvest. So in this study, we investigate the effect of negative and positive rainfall shocks on millet production and millet price variety in Niger. And we find symmetric production responses to moderate rainfall shocks, but we find that strong negative rainfall shocks have a much stronger impact than strong positive rainfall shocks. We also find that negative rainfall shock exacerbate price seasonality, meaning that the decreased price in the post-harvest season and increased price in the lean season. And we find also that negative rainfall shocks lead to decline in expected. So we actually explain the effect of negative rainfall shocks by the fact that they lead to a decline in expected income that farmer will receive from production of all other crops, and that will induce sell low, buy high strategies that you observe in the literature in the marketing literature in grains market. So we suggest that early warning system programs should monitor the incidence of negative rainfall shock if they want to predict strong millet production shortfalls in Niger. And also we suggest rapid social protection program intervention to help farmers cope with the negative short-term coping mechanism that they employ as a response to negative rainfall shocks.
Okay.
So I'll stop there. Thank you.
Thank you so much, Ange. This is an excellent presentation on a very, very interesting topic. Now, if you could stop sharing your screen, then we can allow Jeffrey to start sharing his screen. So Jeffrey Pagel is next, and he will present on 8 against trees. And Jeffrey's from the University of Barcelona. So let's just make it full screen, and then Jeffrey, you have 15 minutes. Jeffrey? Okay, while Jeffrey is struggling with the full screen, can I also just encourage the audience to please put their questions into the Q&A box. This is, although you cannot see all the questions that have been posted, they will be collected. So please go ahead and put in as many questions as you can. Jeffrey, we can hear you with a long lag, I think. Okay, well, Jeffrey seems to have some connection problem. Ryan, would you be fine with jumping in and starting your presentation now while Jeffrey's sorting out the connection? Okay, good. So then we just need to convince Jeffrey to stop sharing.
Okay, Niclas, can you hear me?
I cannot really understand what has been said. Okay. Ryan, can you start sharing now? So then we're just jumping ahead. And Ryan will start presenting on agriculture and deforestation. Ryan, you have 15 minutes if that's okay with you. Sorry for the slight change of schedule. And
not a problem. I'm just going to go ahead and keep
Jeffrey. Okay, excellent. So we hope that Jeffrey will come back right after that. The floor is all yours.
Great, thank you very much. I appreciate the opportunity to share this work. And this work is joint work with Tivrat Garg, Sarab Singhal, and Yao Pan. And I believe Sarab is actually in the attendance here. So this is a paper about the relationship between agricultural productivity and deforestation. And so as a little bit of motivation here, we know that agriculture is kind of the major driver of global forest loss, particularly when we look at the tropics. Okay? Now, across the tropics, the way that agriculture drives deforestation may look a little bit different. In Brazil and Indonesia, for example, it's largely commodity-driven deforestation for things like soy, palm oil, and cattle. But in a lot of other areas in South America, as well as the majority of sub-Saharan Africa, a lot of the drivers of forest loss is actually shifting cultivation or shift agriculture. Okay? So we know that low land productivity and environmental degradation are common to much of the developing world, right? We find these in similar places. Yet at the global scale, increases in agricultural productivity have allowed for global food production to actually outpace the growth in agricultural land area. So thinking about this implies that these improvements in agricultural productivity, at least on some global scale, have spared some natural land from being converted for agricultural production. Right? Now, we know that low land productivity is a major barrier to economic development. And as such, it's received a lot of attention from policymakers, from economists, from development organizations, trying to find ways that we can improve local land productivity in agriculture. Now, whether local increases in productivity can spare local land for nature is an empirical question, right? And this is important because externalities from land conversion are likely not going to be homogeneous. Right. We have variation in the carbon density of the forest, which tends to be more dense in, say, tropical locations. We have, areas that have larger endemic biodiversity. There are also going to be places in which the local populations are more exposed to environmental and health shocks that may follow from deforestation. Okay. So when we think about these policies that are trying to improve local agricultural productivity, right, what the effect that these types of policies or these interventions are going to have on ecological outcomes is, we argue, ex ante ambiguous. Right? We can think about this going in two ways. First, we can think that improved productivity may change the relative value of land in agriculture, and thus may encourage the conversion of marginal forest land for the sake of agricultural production. So this would be kind of the extensification channel. So here we'd expect improvements in productivity to lead to more forest loss. However, higher returns from existing land may reduce the pressure on land clearing, particularly when we're thinking about kind of a shifting cultivation type scenario. So here, this is going to be the intensification channel. So this could lead to a potential reduction in forest loss as the need to shift cultivation is delayed or even prevented. Okay? So which way this goes, or which effect dominates here, remains an open empirical question, but one that we think is really important to try to understand if we want to think about kind of the larger impacts of some of these agricultural policies that are being implemented. Okay, and this is a difficult one to answer because isolating causal effects and the mechanisms is typically really different. It's not random where we see differences in agricultural productivity. It's often correlated with all kinds of other things that make this a challenging question to answer. So this is what we're going to do in this paper. We're going to use an agricultural extension program in Uganda to look at its impacts on forest loss. We're going to leverage a spatial regression discontinuity that was baked into the program eligibility. We're going to find actually that deforestation decreases by about 13%. We're then going to look at some household level data, and we're going to find evidence consistent with this intensification channel. So we're going to see increases in practices like intercropping, crop rotation, manure use, and irrigation. These are all things that have kind of greater improvements on existing land relative to new land. We're also going to find evidence for improvements in productivity as measured by earnings per acre. And we're not going to see an increase in household cultivated area. We're also not going to see differences in purchased use inputs or fuel use. Okay? So taken together, we actually think this is a very optimistic paper. It presents a potential win-win scenario in which the right agricultural productivity enhancing policies may be able to have positive environmental spillovers. Okay. So we think this fits into kind of three related literatures. The first is going to be that on agricultural productivity and forest loss, sometimes referred to as the Borlaug hypothesis. A lot of the work here is either looking at the global scale or making cross-country comparisons, looking at differences in cross-country yields and land area under cultivation. There are a few within-country studies that are notable. Two are in Africa, one in Malawi and one in Zambia, both looking at subsidized fertilizer and the impact that that plays in terms of agricultural productivity. Another paper by Asunciao and co-authors is looking at electrification in Brazil. Again, these are kind of very different policies than what we're looking at, and we're going to have the added advantage of having a nice regression discontinuity design, which we think bodes well for our causal analysis. We also think this fits into the literature on the ecological impact of development interventions. So if we think about development interventions as being on a continuum where some have explicitly conservation objectives and some have explicitly kind of income objectives, we think that agriculture is one of those that kind of lies in between, and given the relationship between agriculture and the environment, this is a really, really important area to think about both development and ecological impacts. And it also fits into kind of this broader literature on economic development and the environment. Okay, so for the 15-minute talk, I will skip the conceptual framework, just in case I had 20. And so we'll jump into the program that we'll look at. So we're going to study the BRAC Agricultural Extension Program. Now, this program provided intensive extension training to model farmers from eligible villages. So farmers from eligible villages could go learn the training techniques, and they would go back to their village and set up model plots and hold training sessions for local villagers. Model farmers also received inputs with a small subsidy that they could then in turn sell at market prices to other villagers, and this was to try to provide these different inputs, but they weren't subsidized for the villagers who were buying them. They were at market price. This was a small subsidy to encourage the model farmers to sell them. Okay, so this is kind of what the program did. Our co-author Pan has found that this program actually improved local food security, which was really the explicit goal of the program. Okay. This program lasted from 2008 to 2012 with the phase out in 2013. And importantly for our study, that only villages that lied within 6 kilometers of a BRAC office were eligible to participate in this program. Villages that were beyond 6 kilometers were ineligible. Okay. So to tackle this, we're going to use a variety of different data sources. We're going to gather a lot of village locations, a little over 5,000. We're going to keep the 800 plus villages that lie within 12 kilometers of a BRAC office. We're then going to use the Global Forest Change data set. This is by Hansen and co-authors. This provides really nice high resolution estimates of baseline tree cover in the year 2000, as well as annual loss estimates. Right? So by high resolution, I mean the 30 by 30 meter level, which is going to be really important given kind of the tight spatial discontinuity that we're working with in the study. We're then going to aggregate forest cover as well as annual forest loss to the villages using a 400 meter radius drawn around the village centers that we have. And we use this 400 meter because this happens to be the median household distance to village center in our household data. And we also play with changing this radius a little bit in other analysis. We're then going to assign the running variable of the village distance to the BRAC office. And what we get is a balanced panel of annual forest loss estimates from 2001 to 2016 at the village level. So before we do any of our other analysis, we're going to just estimate a simple two-way fixed effects model on the inverse hyperbolic sine of annual forest loss here, and then use the residuals from that regression in our regression discontinuity. Now, this is really just to control for any time invariant unobservable characteristics at the village level that we don't see, but are going to affect average forest loss across the sample, as well as common year-to-year shocks. So these shouldn't affect our estimates, just improve the precision, since we're then going to work with the residuals. We also then have some household data. This comes from BRAC's agricultural survey, where we're going to look at households that were surveyed between July and December of 2011. This is a survey on a lot of agricultural practices and some other household characteristics. And we're going to do a similar analysis here, where we're going to assign households to the village. We're going to look at the village distance to the BRAC office as the running variable, and then assign whether these households were eligible or ineligible based on the village location. So here's a map of Uganda. The red dots here are all of the BRAC offices we're going to study. The gray dots are the 6 kilometer, or the gray circles are the 6 kilometer radius buffers, and then the black circles are 12 kilometer radius buffers. So if we zoom in, we can also add our forest data here. And again, you'll see the red dots is the BRAC centers. The blue dots are going to be our villages, and the green represents the baseline forest cover. Red is any tree cover that was lost in our sample window here. Okay. Zooming in even closer, we can really see kind of what our variation looks like. So again, the red dot is the location of the BRAC center. These blue dots in here are all villages that are eligible for this program. These blue dots out here are villages that are similar but ineligible for the program based on this 6 kilometer cutoff. And these are the 400-meter radius for which we're going to use to attribute forest to villages. So we're going to approach this using a regression discontinuity design. We're going to exploit the 6 kilometer eligibility distance that was kind of baked into this program. We're going to estimate differences in outcomes then at the boundary using a non-parametric local polynomial estimator. So our identifying assumptions here is that we don't have any perfect manipulation in the running variable, meaning that the villages aren't kind of moving around, but importantly that nothing else is changing at this 6 kilometer boundary. Okay. So because we don't have explicit data on which villages were treated, all of the estimates you're going to see here are intent to treat estimates. So we can't actually get treatment on the treated because we don't know which villages were treated. Okay.
Ryan, so we show 5 minutes. Great.
Okay, so we can show that villages on either side were very similar, both in terms of kind of their density as well as their baseline forest cover. We also show that they don't vary based on these geographic characteristics. So elevation, distance to nearest road, distance to nearest water source. These are all very, very similar. So we're going to look, the other thing that's really nice is that we have forest loss prior to this program. So we can estimate this RD in some kind of placebo setting before the program takes place and to see if we find any kind of discontinuity. So here we're going to estimate our regression discontinuity on residualized forest loss prior to the program starting. And here again, 0 is going to be our eligibility boundary. So anything that is to the left of 0, these are villages that are eligible. Anything to the right, these are villages that are ineligible. And so prior to the program start, we don't see any differences in our residual forest loss. However, and this is the main result of the paper, that during the program, we see a significant reduction in forest loss for those villages that were just eligible for the program relative to these villages over here that were just ineligible for the program. Okay. So we're going to estimate this formally. This is again just basically showing you, the table estimates that correspond to the previous picture. We're going to run this across a variety of different bandwidths. We're going to prefer our 2 kilometer bandwidth just to make sure that we're using the same sample in all of these different regressions. And we'll also estimate it with the CCT optimal bandwidth, 1.5 kilometer, 2.5 kilometer, 3 kilometer, just to show you kind of some variety here. So we see is that program eligibility reduced forest loss by about 13% per year for eligible villages, right, relative to those that were ineligible. And this result remains pretty stable across all of these different specifications. And importantly, when we do the same exercise looking at pre-treatment forest loss, right, we see no significant differences down here. Okay. So this is really kind of the main finding of the table. We then want to go ahead and dive into some of our household results and look at the agricultural mechanisms that might be at play. So columns 1 through 5 here are going to be all different types of agricultural practices that are consistent with things that were included in the training. So manure use, intercropping, crop rotation, irrigation, and weeding. Again, these are all just 0, 1 variables. Does the household use this technique, yes or no? And these is all using that same 2 kilometer bandwidth. Okay. So we find the program led to significant increases in all of these practices. We found the program actually had no effect on the use of fertilizer, high yield variety seeds, or whether or not households were planting perennial crops. Okay, so we think that this is evidence towards kind of this intensification mechanism here. We're then also going to look at some other outcomes. So we'll look at revenue per acre. This is a measure of productivity. We see even though this is noisy, we find a pretty sizable increase in our revenue per acre here. Then we look at kind of extensification measures. So column 2 is looking at the IHS cultivated agricultural area per household. We don't see any difference in this measure as a function of the treatment of the program. And then we look at if we see that, to look to see if this induced any more kind of engagement in agriculture and that agriculture was more productive. And again, we don't see any difference over here. So we believe that this is consistent with the story that we see these really strong intensification effects, but not so much the extensification effects. So just to wrap up here, we find the program avoided deforestation by about 13% in eligible villages compared to those villages that were just barely ineligible. We find that households in eligible villages engage in more intensive agricultural practice consistent with reducing or delaying the need to shift agricultural plots. Okay. We do not find differences in use of firewood, use of purchased input, or use of a cultivated area. And we think that agricultural earnings per acre increase. Okay. So there's some important caveats that are worth mentioning with this study. First, that we believe that factor market constraints here are going to be really, really key. Right? We think that it's that the idea that households are probably labor constrained or maybe credit constrained is going to limit the ability to increase total land under cultivation in the presence of these improvements in productivity. And so if we don't have these constraints, then these ecological gains may not actually exist from these types of interventions. We also recognize that improved agricultural productivity may be accompanied by changes in outside options. In this case, we're able to hold these fixed by looking at areas, villages that are really close together, just on one side versus the other side of this eligibility boundary. But in general, there could be potential general equilibrium effects that could then follow. So, again, these are important caveats in terms of why we find what we find in this setting and may not generalize to others. We also cannot measure whether deforestation is permanently avoided, but even if we're delaying deforestation, there's still value to that. Okay. So kind of our final takeaways is the research on agricultural programs really should consider also testing effects on deforestation, just because these two things are so importantly intertwined.
Okay, thank you very much, Ryan. Thank you so much for that great presentation on such a new topic and new question. Now we hope to try again with Jeffrey. Jeffrey, do you want to try sharing your screen again?
Can you hear me better now?
Yes, it seems to be working well now. Let's see how it works with the slides. Otherwise, maybe we want to switch off your camera.
Oops. Okay, can you see the presentation?
Yes.
Okay.
Cool. You have 15 minutes.
Okay. Well, thank you very much for having me. It's a pleasure to be here. Today, I'm going to speak about deforestation and the community-driven development program in the Philippines. So the motivation for this paper is going to come from two areas, from an environmental perspective and from a development perspective, and then I'll bring them together to show how they're related. So deforestation is a global environmental concern, mainly through the loss of the carbon sink. So just between 2006 and 2015, deforestation accounted for about 9% of global anthropogenic carbon emissions. And this was the second largest source of carbon emissions after fossil fuel combustion. So not only is this a global problem, but there's also local and regional concerns, mainly due to land degradation and a loss of biodiversity. So deforestation can remove the watershed protection, can reduce soil fertility, can increase runoff into fisheries, and then more long-term effects can exacerbate droughts, floods, and landslides, mainly through this reduction in the land's absorptive capacity. On the development side, in recent years, large international institutions and multilaterals are pushing a program called community-driven development. And this is a type of program that supports a bottom-up approach to development. And the way that it does this is it decentralizes the decision-making process to the local level and can best be characterized by the movement of responsibility over resources and planning decisions. So just as of 2019, there were about 219 of these projects across 79 countries, for a total lending of about 21.6 billion. And over the past decade, the World Bank has spent approximately 50 billion on this type of program, or around 10% of its lending portfolio. So where these two areas come together is that donors are actually targeting these CDD strategies as a form of climate change mitigation and adaptation. In general, we know very little about the effects international aid has on deforestation, but more specifically, we know very little about the effects that CDD programs have on deforestation. On top of that, as Alpizar and Ferraro pointed out, little is known about the environmental impacts of actions that are designed to reduce poverty, but it's also in the other direction as the poverty impacts of actions that are designed to protect the environment. So the objective of this study is going to try to bridge these two areas together to see whether there's a contradiction between fighting poverty and protecting the environment. And I do that by asking the question, does development aid have unintended environmental effects in regards to deforestation? So I'm going to utilize satellite generated forest coverage data to measure the impact that a CDD program has on deforestation. So I'm going to exploit two empirical strategies. The first, regression discontinuity design, and the second, the randomized control trial, to analyze a large-scale CDD program in the Philippines called Kalahi SIDS. So first, I'm going to be able to overcome the non-randomness of aid allocation through each of these empirical strategies. The second, I'm going to be able to analyze the same CDD program, but from 2 different time periods. And third, I'm going to be able to exploit a rich data set of sub-project characteristics. So the type of project that was implemented, the number of beneficiaries, construction duration, and cost considerations. So just a quick preview of the results. So I find that treated municipalities on average deforest more relative to the control in both empirical strategies. Some potential mechanisms that could be underlying this result show that indicate that there's some stimulation in economic activity. So I see that through nighttime light, reductions in poverty, different shares of population working in certain sectors, as well as corollary increases in inward migration. I also find differential effects based on the type of project that was implemented, as well as I show spillover effects into neighboring municipalities. So the most closely related paper to this is that of Hess and others, and they're analyzing a nationwide CDD program that was randomly assigned at the village level in rural Gambia. And they find that deforestation increased by about 11, and this effect was mostly concentrated in areas surrounding the treated villages. So where these 2 studies are going to differ is, first, the scale of the Philippines program is much larger. So the number of implemented projects in the first wave was over 5,300. In the Hess context, in the Gambian context, this is about 200 projects that were implemented. Second is going to be the nature of the sub-projects. So in the Philippines context, this is much more infrastructure-based. In the Gambian context, it's either agricultural based or non-agricultural based, as well as the data that I have on these projects. Third is going to just be this unusual ability to study the same national CDD program, but in 2 different time periods. And then fourth is going to be the Philippines context is just going to provide substantial spatial heterogeneity in terms of economic, social, and ecological diversity. So the main strand of literature that this is going to relate to is that of infrastructure's impact on deforestation. And so there were some mixed evidence on the impact that infrastructure has on deforestation. Recent evidence by Asher and others investigating construction of roads in India shows there's differential effects. So the construction of rural roads had 0 effect on deforestation, but the upgrading of the national highway caused substantial forest loss. And then recent work by Ben Yashay and others are investigating exposure to Chinese development activities. And they find that in Cambodia, these projects actually slowed forest loss. And then in Tanzania, they actually sped up the rate of deforestation. Also in the paper, there's some results that relate to increasing growth or well-being on deforestation. And this I'm not going to have enough time to get into today. Okay, so the KC program had really 3 aims. The first is poverty reduction, improve local governance, and then also improve social capital. And the way that this program does this is they provide block grants to communities. Communities then self-identify what their development needs are. And then they use these block grants to finance public infrastructure or services, which they call sub-projects. So in the first wave that we're going to be looking at between 2003 and 2008, the KC program provided aid to more than 4,000 villages in 184 municipalities. So I have data on all 5,304 projects that were implemented. This was about $86.6 million in funding, or around 450,000 per municipality. In a later wave of the program, between 2012 and 2015, the program was expanded between the government and MCC. And this was around 58 million in funding, or again, 450,000 per municipality. So this is a fairly large influx of funding into these municipalities. So just to get some flavor on the type of infrastructure projects that were implemented, these are really roads, water systems, schools and clinics, and then there's pre and post harvesting facilities, and then economic and support buildings, so such as markets or trading centers. Okay, so the data I'm going to use is this Hansen data set. So this is pixel level data with a high spatial resolution of 30 meters by 30 meters. What I've done is I've just zoomed in on a northern municipality in the Philippines to kind of show the data. So here, each color represents a binary indicator if over 90% of this pixel has been lost in a given time period. And then black is just going to represent no change or no deforestation. If we zoom in, we can start to see, really the pixels, the individual level pixels and groupings of pixels. And so what I do here is I'm going to just construct a column vector for the total square meters of forest loss in a given municipality and in a given time period. Okay, so there's going to be 2 empirical strategies. The first is going to be an RDD. So municipalities within 22 provinces were first ranked according to a poverty mapping methodology. And then development aid was restricted to the poorest 25% of municipalities within a given province. So here what we see is that participation increases by about 52 to 53 percentage points across this threshold. I can then just plot the forcing variable, so this relative poverty ranking against the probability of a municipality participating in this program. So we do see that there's a jump across this threshold. I then look at robustness checks, so the discontinuous effect on other covariates, and I find no effect. I look at a density smoothness test to see if there's any effect, and there's not, as well as whether there's sorting across this threshold, and there's really no evidence for this either. There were some compliance issues with the program. These were mostly exogenously induced, and I'm willing to talk about that during the Q&A. So the specification that's going to be employed is just going to be a fixed panel regression. There's going to be two dependent variables, so the log of deforestation and then the absolute level of deforestation. The main variable of interest is just going to be a binary indicator if you're eligible or not for this program. I'm also going to include the forcing variable and an interaction between eligibility and the forcing variable, as well as a battery of controls. Okay, so then in the RCT, so from 2012 to 2015, the program was further expanded. 198 municipalities were either assigned to be in the treatment or the control. So how the allocation worked was participation was again based on this poverty level experience, as well as prior experience with the KC program. So if you had a poverty incidence of over 70%, you automatically received this program. Less than 33%, you were ineligible. And thus the randomization happened in between these two. So between 34 and 69%, you were randomly selected to participate in the program. So again, we're gonna have a fixed panel regression, two dependent variables again. The main variable of interest is just gonna be whether you're treated or not in this program. I will also include strata pair triplet dummies that are just based on a matched municipality pairing, as well as a battery of controls. Okay. So the main headline findings of this paper is that this program caused so statistically significant effects on deforestation. So here in the first wave, I see that eligible municipalities on average deforest around 236% more than the control. And this translates to around 957,000 square meters. I also run some robustness checks to see with the optimal bandwidth, and the results remain the same, are very similar, and as well as movement along this bandwidth selection, and the results again remain very similar.
You have 5 minutes.
Okay. In the RCT results, I see that we see that treated municipalities on average deforest 265% more than the control, and this translates to around over 2 million square meters. Okay, so some mechanisms that are underlying this result. I first look at poverty. So this was just one of the main aims of it. And there's kind of mixed evidence that Bush and Fretig-Allon find in a meta-analysis that the link between deforestation and income is just unclear. So we do see that prior to the program, eligible municipalities do have a higher poverty incidence, and at the end they have a less poverty. And by 2012, we see no statistical difference, but this has reasons to deal with how the program was changed after 2008 and 2009. Then I look at nighttime light. So this has been used as a proxy for economic activity, as well as economic activity in subnational administrative units. And we know that different aspects of the built environment can increase deforestation. So this we see through transportation costs to the market, as well as the transformation of remote economies. So here what I see, I leverage satellite data of nighttime light. Eligible municipalities on average have 26% more nighttime light than the control. And if I lag this, we see about 16% in the following period. Some labor changes by sector. So here we see that we're really concerned about the expansion of agricultural lands. So we see that the sectors of agriculture, fishing, and forestry increased, as well as manufacturing. There were decreases in transportation, storage, and communication, and no changes within mining and extractives. Last, I look at our other possible channels. So this is through population, immigration, and wood for cooking fuel. Really, the only effect we see here is through migration. Okay, so heterogeneous analysis. So then I look at different types of sub-projects and what their effects are on forest coverage. So first here, what I do is I classify these into 5 categories. So infrastructure, education and health, water and electricity, water protection and support. And then I run the same empirical strategy, but with an interaction between the eligibility and this type of project. And we see that the largest impacts are coming from infrastructure sub-projects, followed by economic support and then education and health facilities. Lastly, what I do is I look at spillover effects. So do the implemented sub-projects have spillover effects into surrounding municipalities? I first create a data set of deforestation in every municipality of the Philippines, and then I remove the treated municipalities out from the data set. So in column 1, what we're seeing is the extensive margin. So what is the effect of having a treated neighbor? Here, I find that with each additional treated neighbor, deforestation increases by about 10%. And in column 2, we're looking at an intensive margin. So how many projects did your neighbor implement? And here we see really no effect. At the moment, I'm working on implementing Conley standard errors that is going to be able to account for kind of the structural dependence or interrelated dependence that these municipalities have. And again, I'm finding very similar effects to this. Okay, so the study finds empirical evidence that treated municipalities on average suffer from more deforestation relative to the control. There's heterogeneous effects based on the type of projects that are implemented, as well as the type of the number of beneficiaries, construction duration, and project costs. And also we see that there was some type of stimulation of economic activity. So this is through nighttime light, reductions in poverty, increased sectors in certain populations, as well as inward migration. And then I go through internal documents, either from the implementing level or from the funding level. And there's kind of 2 areas of reform that are revealed. So the first is a more comprehensive approach to environmental safeguard policies is needed. So the first is environmental assessments regarding forestry and natural habitats need to be included, which there are not at the moment. The second is mechanisms that should be put in place to monitor and evaluate the impacts that certain sub-projects are having on the environment. So we see that infrastructure projects are having the largest impact, and maybe we can allocate more resources toward the monitoring of this type of project and relative to others. And lastly would be implementation support. So technical manuals are provided to these municipalities on how to run the program. So these manuals could include sections on sustainable development, as well as community facilitators who are going to these municipalities to train volunteers, could be trained in environmental sustainable building practices, in which this knowledge could then be transmitted into the municipality and village. So thank you very much for your attention, and any questions are greatly appreciated.
Excellent. Thank you so much, Jeffrey, for this very, very interesting presentation. And thanks also for the flexibility in just briefly swapping slots. Also, thanks again to Ryan. And just after having watched both presentations, I'm really looking forward to Jeffrey's questions for Ryan's presentation and vice versa. In the meantime, if you have any questions, please do put them into the Q&A and we will curate them as we said. And now we started the day with a session on spatial development, and now it's Marcel's honor to close the day with this session, again, closer to spatial development. So Marcel, the floor is all yours. You have 15 minutes.
Sorry, but the button to unmute myself disappeared. So yeah, but now it's back.
No problem.
That's good. So I'd like to talk about the evolution of built-up areas in Ghana since 1975. It's joint work with Fafchamps. We all know that African population has been growing rapidly. It will reach probably the forecast about 2 billion by 2050, about 4 billion by 2100. So that's a massive increase. At the same time, it's urbanizing rapidly. It's already about 30% urbanized, more or less, and it's predicted to go at least to 50%. So we're going to have lots of very, very large megacities. So that's a formidable challenge for policymakers. How do you plan infrastructure placement in such an environment? There's been a lot of research on this. Mostly it's concentrated on these large metropolitan areas, quite perhaps understandably. In this paper, we do something a little bit different. We look at smaller towns and dispersed settlements and their location across space, because actually a lot of the increase in population will happen there. And we would also like to know how this settlement will develop over time, whether we can predict it, and the idea that if we can predict at least certain aspects of it, we'd be in a better position to plan various type of infrastructure, roads, health centers, schools, and all that. So that's the logic. To do this, we use a high density construction that comes out of the Global Human Settlement project, led by the European Commission. And what they did, they took satellite imagery from Landsat and other satellite projects to construct a build-up density data. And they have different cuts to the data, but we use the 250 meters by 250 meter cut that predicts a percentage of that 250 by 250 meter area that is built up, by which we mean buildings, sidewalks, parking lots, things like that. We focus on Ghana. It's the advantage of Ghana is that it's got a peaceful post-independence history, rapid economic growth since the 90s, and I would argue it's geographically representative of much of West Africa. It's got forest and drier areas and so on. There's a literature on this, which I won't have the time to cover, but a lot of this literature, as I said, it focuses on large cities, and there's a much smaller literature on the placement of new towns, and we're trying to contribute to that. Let me first say a few words about the conceptual framework, because probably many of you haven't thought about this issue of placement of population across space, except perhaps two of our authors here, the ones that presented these two fantastic papers on environmental issues. Obviously, if people want to move into a forest area and to build a village there, they will obviously cut some trees and deforest part of the area. So it's, the placement of population on the landscape is very, very closely related to environmental issues. And if everybody was in one big city, of course, the nature environment of the city would probably disappear, but it would leave lots of space around the city for nature to flourish. So the concentration of population across space can be seen as a way of certainly reducing deforestation and favoring the environment. So that's also one of the side interests of this project, although we don't formally discuss it. The framework we have is going to be focused on these cells, these little squares we have. There's 3.8 million of them, so lots of them, and we observe them 4 times at these 10 to 15 year intervals. And as I have explained, these are the data set is basically predictions and machine learning predictions of the proportion of built-up area that varies from 0 to 100%. Actually, most of the cells show no buildings on them. So, in 1975, with 98.5% of these cells with no buildings on them. That falls to 93.8% in 2014, 40 years later. So, that's a significant reduction in proportion of areas that have no buildings whatsoever. At the same time, within the at least partially built up areas, the proportion of those built-up cells that is at least 90% built up according to this ML algorithm, that rises from 7 to 12%. So there's a large increase in what I would regard as like urban centers and so on. Okay, so that's just give you a picture. We have a little bit of information on agroeconomic zones. I won't talk too much about that. We have information on roads. I'll say a few words about that. We have no information on population, employment, occupation, activity, production, and all the things that we care about. All we have is these buildings. Okay, so we're going to take buildings as a kind of like people take nightlight. We're going to take buildings as a measure of settlement and population activity, and we think that if people manage to live somewhere, they must have some kind of income from that place. We are going to be focusing on, so in terms of conceptual framework, there's 2 bodies of theoretical work that we're going to be drawing from. One is about how rural towns and their hinterland self-organize across space, and that goes back to a seminal work by von Thunen in 1826, and further work by Isard in 1956, and I'm going to show you some so the way we use this literature, and there's also a more recent literature on urban periphery. So let's talk a little bit about rural towns. And so if you in the concept of von Thunen, you would have a little urban, little rural center there, like a little town, market town. People are, and then you have all these buildings around. These are the farmers. They're kind of around the town. They travel to the town to sell their wares and buy things. And so if you have a low density settlement, what happens is that all these little villages are spread over the landscape. They don't necessarily, close to each other. And if you look at the spatial correlogram, so basically if you look at the correlation, so spatial correlogram, just a second, the spatial correlogram is constructed by taking all the dots on this rectangle, all the dots, think of these as a whole bunch of pixels, construct all the pairs of dots, and then you look at the proportion of these pairs of dots that are built up, and you relate this with the distance between the pairs of dots. That's a spatial covariagram or spatial correlogram. And so this spike here means that there's a lot of dots that are close to each other. These are the little villages, but otherwise it's kind of there's no pattern there. It's just basically flat because they just across the landscape. If you were to go to a von Thunen or Isard pattern where you have this hexagon shape, equally spaced villages, they squeeze each other's hinterland, and eventually they kind of space out because farmers here, they either go to this village to sell their stuff or this one, and that becomes a boundary between the hinterland, the basin of attraction of a village. So you get this kind of, if the landscape turns into something like that, roughly, then you get this spatial covariagram that has these very steep regularities in them, and that's because you have this regularity here is a proximity between these villages. Okay, and this one is the proximity between these villages and so on. So you get this kind of pattern of correlations. So that's we're going to be looking for that in the data. The other one is about what happens about urban growth. Well, first you could look at the upper left graph. You could imagine that the city has got a center there, and then you got this big suburban area around it. And you can imagine that when the city grows, the suburban area grows with it. So this picture just remains the same, it just gets bigger. Okay, just covers more land, but it remains the same. So that would be one possibility. Of course, it would mean that the distance between the center and the edge of this suburban area gets bigger and bigger because this whole circle gets bigger. Okay, so distances grow. So because distances might be a problem for travel if you think about commuting. So basically, what could happen also is the opposite, which I've represented here, where the town grows, so it densifies. So you have a core that's heavily dense, that gets bigger and bigger, but it gets bigger it basically grows within its hinterland, and eventually, it chews up most of the hinterland. So you don't see the growth of the footprint of the whole city. What you see is that the city densifies within its own hinterland. So we can also look at that in terms of what is the pattern that you get from this. But if you look at the distribution of partially built up area, these are partially built up areas, these are heavily built up areas, you would see that here, if the whole thing grows at the same time, then this distribution of density remains the same. Here, what happens is that the low density areas fall, the high density areas grow. So you get this distribution of built up areas that changes over time as the city grows into its hinterland. So that's what we look at. We construct. So I've already described this part. We also look at neighborhoods. So these are, so think about each cell is a square. So we have a square. It's going to have 8 neighbors, 3 here, 3 here, 1 here, 1 here. So that's 8. Then that's what we call neighborhood 1. And then You can also look at then the neighborhood around that. That's 5 and 5 and 3 and 3. That's the second neighborhood. So it's 16 cells there. That's a second neighborhood. So we can also look at the neighborhood effect. This is what the data looks like. For instance, this is a place kind of in the middle of the country called Yeji, just random coordinate. You can see there's a little settlement here in 1975. 1990, that settlement has gotten bigger, and all the little settlements, like this one, for instance, about the same size as this one, was in 1975. This one as well, and they crop. And then this, by the time you get to 2000, 10 years later, those have grown. This one has grown even further. It's the new ones have and so on. And this is 2014. So you see this kind of a expansion of settlement. As I've shown, you go from 98.5% no settlement to 93.8% no settlement. So you get a lot of increase in settlement. Population has grown a lot for this period.
You have 5 minutes left.
Yeah, 5 minutes. So that's just the general evolution of built up roads. Actually, if you want to predict what's going to happen, roads have a strong predictive effect. So if you look at past roads, the road in 1976, the very beginning, and look at whether they predict settlement in the future, they do predict a lot, even 40 years later. See the difference between having a road in 76 and not having a road, you get a very large difference in settlement. The same thing for 86 roads. We also construct transition matrices. So you have in build-up. So you will have these familiar with transition matrices. So once you construct the transition matrices, you can, if you assume that the frequencies in the transition matrix don't change over time, so basically the same economic processes at work, you can make predictions about the distribution of build-up area in the future. So that's what we do as well. So first of all, for those of you who are familiar with zip flow in city size, that zip flow would have a linear relationship here. It's definitely rejected here. So there's no zip flow here. In terms of the distribution of build-up proportion, basically it remains flat, remains the same. But this part here, which I've excised, I haven't shown you the 100% build-up. That part just goes up a lot. When it goes from 7% to 12%, and if you predict to the future, you get even bigger concentration in cities. Okay, so these are forecasts for 2092, and you see that you get a lot of the build-up area that is taken up by these heavily dense agglomerations. So what we see is what is predicted by this model and by the data is basically that cities will grow within their hinterland, which is actually quite reasonable given that you can't just travel in infinite distances. This is showing you again in another way the role of roads, historical roads. They have a very strong effect on, you can see much less unbuilt proportion in places that were close to historical roads. Neighborhood effects, very strong neighborhood effects contemporaneously. So if you look at correlation about, so if you have a neighborhood, if there is a lot of population in your neighborhood 1, that's correlated strongly with your own build-up area. And if you have a lot of build-up in neighborhood size 2, controlling for neighborhood size 1, you see a negative effect. So basically, these neighborhoods distance 2 are basically competing with you in terms of attracting population. So they're showing that there's this very local attraction or this correlation in terms of population density, and it's even emphasized by roads. If you look over time, what you get is actually, what you see, of course, is that the whole neighborhoods grow. So basically, if you had population in the past, then you predicted to have more population in the future, even at distance 2. So you get this strong agglomeration effect. So what you see is that people agglomerate over time. That's what is predicted.
Yeah. If you look at 1 minute.
Yeah, if you look at roads, it's again mostly the big roads that predict population. Finally, if you look at these covariograms, remember I was showing you that if there had been some regularity in placement of small towns and villages, you would have had these spikes here. We see nothing like this. We construct, there's a lot of work behind these graphs, but there's nothing here over time. This is a different level, or these are distance in kilometers, nothing there. This is even distance in longer distances, nothing there. So to conclude, fall in and build cells. It's not like the cities grow, the country is growing through some kind of suburbanization expansion, like urban sprawl, in the sense of this, low population density suburban areas growing and spreading into the around cities. That's not what we see here. Rather, the cities tend to be the big cities growing within their hinterland. But of course, we do see a gradual growth of little settlement, scattered settlement across the country that suggests agricultural population, neighborhood effects, and rural densification, as I've just talked about. So that's all I have time for.
Excellent. Thank you so much, Marcel, for this great presentation to round off the session today. Now we have still 15-20 minutes for some Q&A. Meanwhile, let us start with questions for Ange. So we'll go Ange, then Ryan, Jeffrey, and Marcel. And I guess we should just first maybe collect one question from the audience. So Rabbi Shandio had a question for Ange. So please, Rabbi, unmute yourself and ask your question live.
Hi, so I just wanted to ask that, so the mechanism that you talked about for the positive rainfall shock was that the price would increase in the area. But my question is that if there's a positive rainfall shock, wouldn't that actually increase production and actually decrease prices in the post-harvest time? Because that's the time when the supply would be even higher than it was before. So I'm kind of confused about the effect here.
Thank you, Rabbi. I'm not sure if I'm pronouncing your name correctly, but so that's the very, that's what we are trying to sell with this paper, basically. So those are perverse marketing behavior that you are observing right there. But so what is happening, and we don't have data to test this, but we are working on another paper right now that is actually testing this, is that positive weather shocks actually kind of relax the credit constraint that farmers usually have in sub-Saharan Africa. And then, what happens is that it increases the income that they get from selling all other crops, that they are producing. And when that happens, basically, farmers are not obliged to actually go to the market early on in the post-harvest season to sell their millet, right? Because what they are looking for are arbitrage opportunities when they know that prices are going to go up later, later in the lean season. So they are looking for that time to actually sell their product. So when they have positive rainfall shocks, they can sell cash crops that they produce and store most of their millet, sell it later on. So early on, what happens in the post-harvest season is that many farmers are trying to store their product, and that actually have a positive effect on price early on. And you see the opposite effect with negative rainfall shocks. And like I said, we don't have data to test it, but there's actually even empirical evidence of this in the literature. So there's a PGAU paper by Burke and Miguel that use an RCT in Kenya to show that when you give farmers credits, it allows them to actually store their products in the post-harvest season and to take advantage of arbitrage opportunities. So that's what is kind of explaining the perverse, marketing behavior that you're observing. So.
Got it. So it's basically displacement. Thank you so much.
No problem.
Thanks a lot. And then the next question is from Lisa Martin for Ange.
Yeah,
Lisa?
a couple of questions, but I'm going to pick one first. So I guess this first question is about how local the effects are. So how strong are price co-movements between markets in Niger? And is there a way that local weather shocks aren't really reflected in the local price because the price is also kind of impacted by fundamentally imports from different local markets? So how strong?
That's actually a good question. And so we didn't specifically dive into the price movement analysis, but there's evidence. I think Jenny Akers has a paper that studies, the movement of prices between markets in Niger, and it showed clearly that shocks on some important markets can actually send waves to other markets around those markets. But in terms of how imports of millet from other neighboring countries can actually affect the effect that we are observing, one that can be important is import of millet from Nigeria. So Niger shares a large border with Nigeria, and in times of negative weather shocks, when they have a shock and low millet stock in Niger, they receive a lot of import from Nigeria. But the issue with that is that since you can see our study is using district level data, so we could have control for import, but it would have been a year level data. We wouldn't have the variation at the district level. So we're expecting that the year fixed effect that we include in our regression is taking care of import from year to year in the analysis, basically.
Okay, great. Thank you so much for that explanation. And we do want to make at least one full round. So let us move on to Ryan, and maybe, or hopefully, we can come back to Ange because there's more questions. So the first question for Ryan is from Tilman from Karna. So Tilman, if you could please unmute yourself and ask your question.
Hi, thank you, Niclas, and thanks, Ryan, for the presentation. I would have two questions. One is about the interpretation of your main result of that you find this difference in forest loss, but mostly it seems to be right at this eligibility boundary. And I'm just wondering, in terms of understanding this result, whether we would not have expected like a level shift throughout the area that got treated, so all the way on the left of your eligibility boundary. And secondly, in terms of interpreting like the conclusions, could you say something about whether these villages were like situated in contexts where the forest that could have been cut was like pristine, thick forest, or rather open landscapes that were already used for agriculture before? Thank you.
Yeah, so let's see. So for your first question, why do we see this effect kind of concentrated, kind of closer to the bandwidth or closer to the cutoff in terms of kind of the distribution? If everything were kind of the same, we would expect to just see kind of this level shift for all of the residuals to the left. But keep in mind that as you start moving further and further left in our data set there, you're actually getting closer and closer to larger cities, because this is where the BRAC offices are typically in places that are a little bit more urbanized than the villages that we're looking at. So if you look at the pretreatment, those residuals are actually above what we would have predicted. So you have kind of systematically positive residuals once you get closer to the BRAC center, once you're within 2 or 3 kilometers of the BRAC center itself. And so if you were to think about this more as like a difference in discontinuity, then you would see kind of this whole level shift right there. But because you have these areas that are a little bit different than the ones that are closer to the 6 kilometer boundary, we think that's probably why we're seeing the effect kind of concentrated there and kind of that downward slope leading up to the eligibility boundary, rather than just a kind of a level shift. So that's for your first question. For the second question, is this kind of pristine forest that we're thinking about? It's not in the sense of like what you would see if you were looking at, deforestation in like the Brazilian Amazon or something, where we really think about this as kind of a frontier where you have, either settlements, agriculture, and then there's a border into kind of this very dense forested area. In general, there are some areas, there are some protected areas in Uganda that are a little bit more kind of set aside and densely forested like that. In general, as you saw from the baseline tree cover, most of the villages have about 30% tree cover in them. With looking in this 400 meter, and this is it's kind of like patchwork or relatively evenly dispersed throughout. So it's not just that you have a village that's right on kind of this forest frontier and all the expansions happening into it. So I believe those are your questions. Yeah.
Excellent, thank you so much. So then we had one further question from Abby Kadir from, I believe, the University of Sheffield. Abby, if you could ask your question.
Yeah, very good. My question is just very basic at the presentation on agriculture and development, which is very interesting. Rather, the way I think about the link between deforestation and agricultural productivity is the other way around. Particularly if you put complications such as population expansion leading to deforestation, leading to soil fertility loss and soil acidity, alkalinity, and then a loss of agricultural productivity. So did you think about the other way or the other channel of the correlation or causation in this case, because you have evaluated a program?
Yeah, so we think that's a really important aspect of what's going on here, is that this kind of shifting cultivation, you know, you have smallholder farmers that are working a particular agricultural plot for a number of seasons until it no longer is as productive as it was, and then they shift cultivation into, you know, an area that was forested, you know, cut down trees, maybe burn the trees, and then start cultivating in that area as well. So in that sense, I think that is along the lines of what you're saying of deforestation being, you know, connected or leading to agricultural productivity. You know, shifting cultivation, if it were absent, you know, growth in population pressure and certain other things that were going on, if you could allow the land to stay fallow long enough for the natural vegetation to grow back, it could be a sustainable practice, in which case we wouldn't be too worried about it. In a lot of these contexts, though, with the population growth, land isn't staying fallow long enough, and so that's what's leading to kind of this net forest loss. So things, you know, like the practices that were promoted in this program, or potential substitutes, either, you know, subsidized fertilizer that we've seen in a couple other settings, we think is potentially being able to delay or maybe even reduce the need to shift cultivation if you can improve the productivity of the existing agricultural land. So in that way, we're thinking about that these programs might be able to kind of break the link that you're thinking of in terms of where you require deforestation to then maintain your yields or your productivity.
Excellent, thank you so much for that answer. Jeffrey, did you have your hand up? So you're on mute, yes.
Yeah, I have a question for Ryan as well, which is kind of along the same lines. But first, I would like to say, Ryan, your work has been quite influential throughout my doctorate, as well as TVRATS as well. So thank you for that. My question is really in regards to, like, how do your results relate to whether on the farmer's land tenure, and how does this affect your results? So on one side, this can affect whether the farmers choose to intensify their production, but on the other side, you know, this can affect the value that they see of the ecological benefits of preserving the forest around their plots. So I'm just kind of curious as to how you guys are thinking about this.
Yeah, well, I know that you've got a paper thinking about land titling and forest loss in a different setting. So the question doesn't surprise me. You know, in our setting, because of, you know, we have this spatial regression discontinuity is at this kind of this relatively arbitrary spatial boundary. We haven't thought too much about the role of, you know, kind of land rights and property rights and so on, because we haven't been worried that's correlated with, you know, the boundary, whether you're eligible or ineligible. So in terms of from an internal validity standpoint, we don't think that you know, has a huge effect. However, we've been thinking about that there might be some regional differences that we could exploit. So then look for heterogeneous impacts from one region to another region where we might have kind of different property rights regimes. But yeah, that's a great question and analysis that we haven't quite yet done.
So that's an excellent move towards actually questions for Jeffrey. I actually wanted to sneak on one on my own, and maybe Jeffrey and Ryan can kind of both comment from their slightly different perspectives here. Because Jeffrey, if I do understand your paper correctly, then basically what you're saying is that these CDD programs create growth. And we're not entirely sure how they create growth, but we see on these nightlights and these other proxies that there is some kind of action going on. And that then has like an unfortunate kind of side effect, which is this deforestation around these places. Now, how does that compare to the kind of growth or welfare effects that we see in Ryan's paper? I think that was my question, but please first correct me if I'm wrong, if I misunderstood your finding.
So the question is really related to what type of welfare are we seeing within
As in, what kind of growth or welfare improvement do we see in these two different cases, and are they related, or are these really kind of opposing findings, or are they kind of two sides of the same coin?
So I think in my setting is, so the welfare enhancing, we're not really sure as to how it's enhancing. So we see that there's projects that are being implemented. What I'm trying to get is the geolocation of these projects. So then I would be able to disentangle kind of the mechanical aspect of just building some type of infrastructure from what would be the secondary growth that comes from, building a road and the economic activity that is generated around that. So I think in this part, there's still a lot of work to be had, kind of trying to disentangle where this welfare is actually coming from, or the effects on welfare.
I'm not sure if Ryan also wants to come in.
Yeah, I mean, it's interesting. I think that there's a lot of the more recent work that that Jeffrey cited in terms of thinking about kind of these large infrastructure projects or kind of these other big projects that are meant to promote growth. The relationship that they have to forest loss is actually, I think, a little bit more nuanced than I think some of the earlier literature had told us. Right, specifically, you have these direct effects and then these indirect effects through the growth channel. In our setting, the growth that we're seeing is our important improvements in productivity for smallholder farmers. But the degree to which we think that this is a program that could be scaled up to a certain degree, but it's probably not in the same context as these large infrastructure projects, building roads, electrification, or some of these other projects. So because it's kind of specifically targeted towards agriculture, which is the direct driver, it's trying to change that relationship between productivity and agricultural expansion. That's, I think, why we kind of find what we find in our setting.
Super interesting. Thank you so much. I was also reminded a bit of like Dilip Mukherjee's work on deforestation in Nepal, where he's kind of exactly trying to highlight this nuanced, weird, non-linear relationship between economic growth and deforestation. So I think this super promising avenues for future research. Now, we also have one final question from Oliver Harman for Marcel. Oliver Harman from BSGE, if you may want to come in and ask a question now.
Yeah, of course. Hi, Marcel. Yeah, it was a question on the kind of density on land versus density of I suppose building on land, because I wasn't quite sure in the presentation. And a key question we often get from policymakers is whether to densify their built environment as exists or to lead kind of with urban expansion. And I was unclear how the model accounts for this aspect of urban density, sort of building height, because from my understanding, these 250 by 250 cells, I couldn't understand how you disentangle between a one-story building in 1975 versus like a 5-story building in 2014, for instance.
We do not.
Okay.
So that's a weakness of the data. I didn't have the time to this is by the way an illustration of that. So all the dots here that are black this is Takoradi, one of the larger cities in Ghana on the coast. And everything that's black there is fully built according to this satellite data. But it could all be single-story buildings or skyscrapers. We don't have any information on the density of population in the buildings themselves. So that's different from urban data. For instance, people that look at square footage that's built or that's occupied, or office square footage, or price of square footage of land, which reflects how much is built on top of that. So we don't have that kind of data here. So that's why I focused more on the areas around cities and the areas that are not cities at all. They are rural towns. So that's why I focused on that. Yeah.
Okay.
That's the strength of the data. There are other people who do kind of make large city analysis, and I've left that to them.
Excellent. So I would also have a question for Marcel, but I'm fully aware that we've run over a bit already, so maybe I can ask Marcel offline instead. So let me now just thank everybody for their great presentations, and also thank you so much for the audience for all these interesting questions. This is concluding today's 3 sessions of the CSAE conference, but if you like what you saw today, then there's more tomorrow. So there's the macro productivity session tomorrow from 12 including on fiscal policy at 12, structural transformation at 2, which should be quite interesting for many people that have presented or that have asked questions today, and then also on taxation and tax administration at 4 p.m. GMT. So thanks again to all the speakers. It's been a pleasure to have you. Thank you so much, and take care, everybody. Bye.